Assignment number 1. In this assignment, we're gonna explore the capabilities of drones. The way to do that is to start, instead of with actual physical drone, is by simulating. Our main tool in this mission gonna be a mission planner. In this example here, my drone is somewhere in Florida, USA. And the topic of our first part of this mission gonna be mapping or designing a route, a set of waypoints, in order to allow a simulating drone to map an interesting place in Florida. And we're looking at the Epcot Center. So let's drill in the Epcot Center. I'm using Google Earth here. And what you can see is that this is the Epcot Center. And actually there's a mistake in Google Earth, and it maps the Disney World somewhere in the forest. Obviously it's somewhere here where the Mickey Mouse parking lot or whatever it is there. We're interested in trying to map this region. Looking in zoom in, we can see some 3D objects. In this region, there's like a nice ball in the Epcot Center. There's some high trees, different types of buildings, and so on and so forth. Our starting point going to be somewhere here, which is our home point for the drone, and the region of interest going to be in a way this mapping somewhere in between, in the middle of the lake, and going back all the way that. Your mission is to design a route, a set of waypoints, such that a drone that will follow that route will complete the mission in less than 20 minutes, which is the maximum battery of our simulating drone, and will be able to take a lot of photos, which will combined will cover the entire region of the Epcot Center. Again, starting from here, going wherever you want, but the entire such region should be mapped. Obviously, if your drone flies very high, it may cover the entire area in few photos, but their photo is going to be in a low resolution, and vice versa. If your drone flies really low, obviously it will take very high resolution images, but those images will be of a small area. Then in order them to overlap, you would need a lot of photos. And recall that you only have 20 minutes for flight, and obviously, if your drone flies really, really fast, then obviously taking a photo might be not as sharp as when it flies in a low pace. So your simulating drone starts here. It should take photos that covers the entire region of the Epcot Center. The entire details of the map are going to be given to you in the exact definition of the assignment, but keep it simple. The notion of this assignment is to design a maximum amount of 100 photos taken by a simulated drone of the Epcot Center. Some of the photos might be vertical, or some of them might be horizontal. You might be interested in taking images of this roundish structure, maybe not from above, but from the horizon, or from 45 degrees angle, and so on. So, in a way, you need to design a route, you need to design a set of waypoints, and in each waypoint, or in each segment between waypoint, you need to design where you want to take the images. A maximum number of 100 images should be sufficient in order to cover this region. This is the first assignment, the first part of the first assignment. Two types of output are required in this assignment. One of them will be the mission, the actual mission you plug to your simulated drone, and the other one would be the simulation output, which is basically a very detailed log of the simulating drone, which basically gives you in a high frequency, in a high sampling rate, the state of the drone, which is the position, the accelerometer, the gyroscope, the angle of the camera, and so on and so forth. In order to be able to simulate the drone in Mission Planner, Some detailed information would be giving you, but this is going to be done in a separate tutorial. So for now, we covered the first part of the first assignment. The second part of assignment 1 is to perform an actual photogrammetry of a region. We've supplied you a set, actually two data sets of images of a drone that actually flew over the Ariel University in some pattern and took images, took photos every 10 meters or every 5 seconds. Some of the images are in high resolution, some others may be a little bit blurry. And your task is to take a look at those images and find an open source or an available software for photogrammetry. There are quite a lot of those. Some of them are free to use open source. Some of them are free to use for trail. Some others might be commercial, but for students, you can have few trails. Whatever you find is okay, but a large portion of this part of the assignment is to find a tool that will allow you to perform photogrammetry. Photogrammetry is the process of taking several images and combine them into few outputs. One of them will be a point cloud, which could be thought as a set of 3D points, and that together represent some sort of a surface of the Earth or the region of interest. Another output would be a mosaic, meaning a combination of the images into one big image. And the third one will be a kind of a surface or a mesh of the photogrammetry or the point clouds. There are quite a lot of those softwares. Some of the most popular are Pix4D, another is Altezur, Drone Deploy, and there are quite a lot of open sources. If you go on GitHub and you Google GitHub photogrammetry, you would find a lot of them. Some of them are more targeted towards drones. Those are the types you want to use. We're mostly interested in photogrammetry of a large region, say a few hundred meters over a few hundred meters. And for that, again, we supply two types of data sets. And you not necessarily need to use all the images. We also supply you a video of one of the flies of the drones. You need to find the best images. There's no reason to take, 10 or 15 images that overlaps of the same region. But maybe if it's a complicated region, you might want to use a higher overlapping of the images. But if it's like a flat, parking lot, then a low overlapping would be good enough. And the end result should be convincing in terms of the way it looks, the 3D model, and the point cloud. Obviously, if you have a building and it looks like a building from the point cloud, we're happy about it. If you have a region and it looks like a set of like randomic points all around the place, then we're not very happy. And if there's very few points altogether, meaning they overlap, the software will be unable to overlap those or to correlate those images into a photogrammetry, then we're not so happy. In order to simplify the task of finding the right tools or understanding the fine details of the first assignment, we supply the following. First of all, a mission-like, but not necessarily of the region of Disney World, but for different region where some other students have designed a relative good route for a drone to map. We also supply few good examples of photogrammetry, but again, not from the exact regions of or from the exact data set you're using, but from a slightly different data set. Good luck.